All right, so today what we're going to be doing is working on the work and power practice problems. All right, so let's go ahead and get started. It says a 105-gram hockey puck is sliding across the ice. A player exerts a 4.5 Newton force over a distance of 1.5 meters. How much work does the player do on the puck? All right, so let's look at this. Number one, equation for work is equal to force times distance. They give us a force and a distance, so this one's pretty easy. Work is equal to, the force is 4.5, I think. Yeah, and the distance is 0.15 meters. Work equals, calculator. Uh, 4.5 times 0.15, we get 0.68 joules. Then it asks, what is a change in puck's energy? Well, work is equal to change or G. So the change in energy is equal to the work, so the change in energy is equal to 0.68 joules. Okay, good. All right, so it says, number two says a forklift raises a box 1.2 meters doing 7 kilojoules of work on it. What is the mass of the box? Okay, so let's think about that. Number two. The work done is, what is it, 7 kilojoules, 7.0 kilojoules. I need to convert that to regular joules. 1 kilojoule is equal to 1,000 joules. I get 7,000 joules. All right. I know that it lifts the box 1.2 meters. So I know distance right? So I knew my basic equation. Work is equal to force times distance. Work is 7,000. Force is what I'm looking for. D is 1.2. The force is equal to 7,000. All right, so we found the force that the forklift needs to overcome, right? Well, if you think about it, if you lift something straight up, what force do you have to overcome? You have to overcome weight, right? The weight of the box is what's pulling it down. The forklift is pushing it up, all right? So if it's moving upwards, that is equal to its weight. So if we want to find the mass, we use that as its weight, and we go weight is equal to mg. Weight is 5833 equals mass. G is 9.8. Mass equals 595. 595 kilograms is the box mass. All right. Let's see. Number 4 says a 875 kilogram compact car speeds up from 22 to 44 while passing another car. What were its initial and final energies, and how much work was done to increase the car speed? All right, this is a basic problem here, so we're working with energy here. Wait. Oh, no, I'm sorry, I skipped one. Number 3. Hold on. All right, number 3 says you and a friend carry each carry identical boxes to a room 1 floor above you and down the hall. You choose to carry it up the stairs first, then down the hall. Your friend carries it down the hall, then up another stairwell. Who does more work? Okay, well, if you think of work, it's work equals force times distance. You guys are carrying identical boxes, so the force is going to be the same. All right? You guys are going to actually travel identical distances because one goes down then up and one goes up then down. So you're actually traveling the same displacement, okay, and the same distance. So if your force and displacement is the same, then your work has to be the same. So you guys actually do the same amount of work even though you took two different ways to do it. All right? So now we're on number 4. I already read it. So what you're going to want to do in this one is take initially, so you get a car. Speeding up. Its initial velocity is 22, I believe. 22 meters per second. Yep. Its final velocity is 44 meters per second. It has a mass of 875. I want to find the initial velocity, or initial energy and final energy. So it's going to be KE initial equals 1/2 mv squared. So you go KE initial equals 1/2 m is 875. V is 22 squared. So I do in my calculator 22 squared times 875 times 0.5. And I get 211,750 joules. Okay? So now I want to find the final. So what kinetic energy does it have here? Well, it speeds up. So let me do this. KE final equals 1/2 mv squared. KE final equals 1/2 mass 875 V 44 squared. So I do 44 squared times 875 times 0.5. I get 847,000 joules. Alright, so I found my final initial energies. Work. Work is change in energy, right? Work is equal to delta KE. In other words, work is equal to KE final minus KE initial. So I plug in. Work equals, final is 847,123 minus 211,750. Work equals okay, 60 joules. All right, so that's how many joules it requires to speed that car up.